Hey there, YouTube. So I'm making a bold claim here. I'm saying that the way that you do random numbers is probably wrong. So now bear with me here. The way that I've generally seen tutorials do number randomization is something like in this first test that I've got here, uh, where you've got your random number, and this is specifically to random integers, not just any random number, but specific to random integers. And less specifically to numbers of uh, certain precision for floating point numbers, but I'm not covering that here. Right now, I'm focusing on integers. And what I've got here is a very simple one or two uh, numbers. So this is a coin flip. So I'm going to show you a coin flip. I'm going to show you a, a random generation of three numbers, and then I'm going to show you a more correct way of doing this, and not necessarily the correct way of doing this. And if you want to see how all of this was put together, down in the description below, I have a link to my video where I did a full run through of all of the code for this. I'm not going to show all of the code for this, just to kind of show uh, this here. You should be able to recognize it if you know VB.NET. Uh, this is kind of the basic way that a lot of tutorials show you how to do random numbers in VB.NET. So right now I've got this little program here. It's going to run a coin flip. It's going to show the value of 1 and 2, the percent that they hit, and then the counts. Now, if I've done this correctly, this actually goes 100 million iterations using the law of large numbers to get an accurate percentage. If I've done this correctly, you should see a 50% chance of getting a head or a tail, a 1 or a 2. There should be roughly the same amount. It's not going to be exact, but we're going to go ahead and run this. And as you see, just right off the bat, we're getting 49, 50% as value 1, value 2. Exactly what we're looking for here. This is a perfect run. And the randomization for the coin flip is great. It's exactly what we're expected. So if you're doing a coin flip, this is a perfect way to do a coin flip. It's just fine. We're getting really close to the random numbers that we're looking for after, what is this here? This is 16 million flips so far. We're really close to 50% on each of them. The numbers are really close to each other. It's exactly what we want to see. Now, the next test I'm going to run is three random numbers. Now, what I'm going to do here is I'm going to say that I've got a number in my head. I'm going to pick 2. I'm going to pick the number 2, just randomly out there. I'm going to pick 2. I'm going to say that my number is 2, and you can pick 1 or 3. Doesn't matter. Pick 1 or 3. Now, my bet is that I am going to have a higher chance of getting the number 3 than you are of getting whatever your other number, or I'm sorry, the number 2. I've got a higher chance of getting the number 2 than you have of getting the numbers 1 or 3. In fact, I'm going to go so far as to say that I'm going to bet the percentages of the chance of getting numbers 1 or number 3 or number 2 are going to be different than you expect. So I bet that in your mind you're thinking if you have a random chance of 3 numbers, just like you're seeing here with random chance of 2 numbers, it's about 50-50. You're thinking it's going to be 33.3 something 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 percent for 1, 2, and 3. Basically 1/3. You've got 3 numbers. Now, here's what I'm going to bet you. I'm going to bet you that I will have, in fact, as much of a chance of getting 2 as you would if you picked both 1 and 3. I'm going to say that I have a 50% chance of getting the number 2, while you have a 25% chance of getting either 1 or 3, whichever one you picked. Now, it seems like a pretty bold claim. I mean, we're doing a random number generation of 3 numbers. As you can see, the random number generation is just working just like it's supposed to. And I'm going to scroll down here. This is the second test. This is the one I'm going to be running. As you can see, I'm doing it almost exactly the same way that the tutorials tell you how to do it. It's multiplying your randomization by 2. I'm still randomizing just like I am there. I'm adding 1 just like I do there. The only difference is that I'm multiplying by 2, which if you look at the tutorials, it's actually going to give me a random number between 1 and 3. This here, the R&D actually generates a random number between 0 and 1, random floating point number between 0 and 1. You then multiply that by what you want your top number to be. If you add 1, then that, of course, adds 1 to your top number and it adds 1 to your bottom number. So the part where it says R&D times 2 is actually going to give me a random number between 0 and 2. Adding 1 is going to give me a random number between 1 and 3. And then, of course, the cin makes it into an integer if you're not already aware of these things. And as you can see, our first test finished off here. We ran through 100 million iterations. We got really close to 50-50. It's not quite 50-50, but it's close enough. Out of the well, basically, if this was 1,000 attempts, you would pretty much have gotten heads 500 times and tails 500 times, just based on these percentages here, rounding, of course. So we're coming down here, and this is the second test. It says just like that first test, we're just adding a third number. We're randomizing exactly the same way. And like I said before, my bet is that my choice of 2 is going to have a 50% chance of landing, while the choices 1 or 3 are going to have 25% chance. And I will explain this later here. So we're going to go ahead and run this. And would you look at that right off the bat? Value for the number 2 is at 50%, and the values for the numbers 1 and 3 are at 25%. Now, I've gotten the actual counts of those hidden here, so I'm going to bet that, of course, a lot more is happening in here than we think, but just to kind of show you, restart this here. And I'm showing you the count. This is the values of 1 and 3 added together down here in the count, and the value of 2 by itself in the count. And as you can see, they are nearly the same. So the values 1 and 2 makes up about 50% of it, and the value 2 makes up the other 50%. Now, why is this, you're asking? Why is it that a random number generation of 3 numbers is 2 the most likely number to be chosen? Is there something wrong with your randomization? Sort of. There is actually nothing horribly wrong with the way that VB.net or any other randomizer is going to be randomizing these numbers. There may be some randomizers, of course, that are horrible, but in this case, there's nothing actually wrong with the random number generation that the R&D command does. It still is generating a fairly good set of pseudo-random numbers. The problem is that you are looking at a range between 1 and 3. And this is, of course, with the multiplying of 2. It's what you're actually getting is a starting range between 0 and 1, a floating point number, and you're rounding that. Now, what that means is that for 2, anything that is at 1.5 to 2.5 is going to be rounded to 2, or well, 2.4999 anyway, is going to round down to 2. So round up, round down to 2. But anything 0.4 or 1.49999, so on, from 1 to that is going to round down to 1. And anything from 2.5 on is going to round up to 3. So for both of those, they only have 0.5, a range of 0.5 that will round to that number, while the center number has a full range of 1 that will round to that number. It actually takes up, in that case, a full 2/4 of the available rounding space. So how do we solve this? The way that I've solved this here is, you can see this is just the code for counting. The way that I've solved this here is I've actually implemented a small loop. Instead of randomizing the 3 numbers, I randomize out to 4 numbers, a full 0 to 4. I want 1 to 3, but I'm randomizing 0 to 4. And what I've done is I've implemented logic that says that if it is less than 1 or greater than 3, if it is basically either of those two numbers that only have that half range, that 0.5 range to round to, I'm ignoring them and I'm trying to randomize again. It's adding a little bit of overhead to the code, but as you'll see here, when I go back and I run this final test here, what I get is a perfect 1/3, or close to a perfect 1/3 of the time I am getting each number. It's a better rounding of the number. So basically, the takeaway of this is if you're doing the rounding the way that it is usually suggested in most of the tutorials I've seen for rounding the numbers, what you are in fact doing is giving a much lower chance of the numbers on the two far ends of your spectrum being chosen. If you're doing a coin flip, it's fine because it's half rounds down and half rounds up. It's just between 1 and 2. But if you're doing anything more than two values, you're leaving out those two ends and you don't actually have a good representation of a random number generator. So that's something to keep in mind. Now, there may be better ways of doing this than the loop that I've implemented here. I'm not perfect. I'm not the best coder in the world. I do code for a living, but I'm obviously not the best coder in the world. Uh, if I was, I'd probably make a lot more than I do now. But this small change, or even just being aware of this problem, can really help you in creating a more accurate generation of random numbers in your code from now on. Hopefully this helped you out. If it did, if you liked the video, please leave comments, subscribe to my channel. If I get a lot of good feedback from this, I'll probably do more of these. So be sure to let me know so I know that this is something that people like. And you know, if you want to, like I said, if you want to see the code behind this, the full creation of this code, so that I'm not trying to pull some trick on you, trying to pull the wool over your eyes, then go ahead and check that out. The code's in the description below. It's kind of long; it's about 40 minutes, but it's the full creation of this little program, so that you can see everything that went into it and double check everything. Make sure that I didn't make a mistake that's causing this, or make sure that I'm not trying to fool you into putting something weird in your code that doesn't really work. But, hopefully this has helped out. And until next time, peace.